Hi, I'm Tony with C3 Controls. In this video, we will talk about the basics of a motor, specifically the different types of induction motors. So let's get started. Electric motors are an integral component of industrial equipment, vehicles, appliance, and just about anything incorporating movement. They convert electrical energy into mechanical energy. Electric motors are powered by either AC or DC sources. Blowers, fans, compressors, cranes, extruders, and conveyors are a few important pieces of equipment that use electric motors. Let's talk a little more about induction motors. An induction motor, also referred to as a synchronous motor, is one of the main types of AC electric motors used in commercial and industrial environments. These motors feature armortisseur windings and work on the principle of electromagnetic induction. The electromagnetic field in the rotor is produced by the rotating field of the stator. The power is transferred from the stator to the rotor winding by induction. There are two main types of induction motors, single-phase and three-phase. So what's a three-phase induction motor? A three-phase induction motor is one of the most widely used types of electrical motors and is an integral part of almost 80% of industrial applications. Its popularity is due to the rugged construction, excellent operating characteristics, speed regulations, and the absence of a commutator. Like any regular induction motor, this motor also comprises a stator and a rotor. A stator is a stationary element of an induction motor. It is a small cylindrical frame which carries a cylindrical core of the rotor. It features different slotted stampings to carry three-phase windings. These windings of the stator have 120 degrees of separation, whereas a rotor is the rotating part of the motor. The rotor features laminated cylindrical slots with copper or aluminum conductors that have joined ends. It is the shaft of the motor. So the stator is the stationary part of the motor, and the rotor rotates. The rotor of a three-phase induction motor is classified as a phase-wound rotor or a slip ring rotor and a squirrel cage rotor. Among the two, the squirrel cage rotor is one of the most common ones. Now you're probably wondering, what is a squirrel cage rotor? Well, induction motors equipped with a squirrel cage rotor are known as squirrel cage induction motors. They get their name because the rotor resembles the rotating cylindrical cage you might find in a pet squirrel or hamster cage. Now, I don't know anyone who keeps a pet squirrel, and I grew up in the foothills of the Appalachian Mountains. But I guess hamster cage motor didn't sound right, so they went with squirrel cage. These motors are available in sizes ranging from fractional horsepower, less than 1 kilowatt, to tens of thousands of horsepower, or tens of megawatts. Factors such as simplicity, rugged construction, and constant speed in different load sizes have contributed to the popularity. Like other induction motors, the squirrel cage motor consists of a rotor and a stator, but they are slightly different. The squirrel cage rotor, cylindrical in shape, is mounted on a shaft. It contains longitudinally organized conductive bars. These bars are made of copper or aluminum and are set into grooves, which are connected at the ends to form a cage-like structure. The rotor has a laminated core, which helps avoid power loss due to hysteresis and eddy currents. Conductors of the rotor are skewed, which helps prevent cogging during the start of the equipment. This skewing ensures improved transformation ratio between the rotor and the stator. Now, the squirrel cage stator consists of a three-phase winding along the core. The stator is placed in a metal housing. The windings in the stator are organized in such a way they're 120 degrees apart and are mounted on a laminated iron core. The iron core provides a reluctance path for flux generated by AC currents. When the motor draws excess current, it is referred to as an overload. This may cause overheating of the motor and damage the windings of the motor. Because of this, it is important to protect the motor, motor branch circuit, and the motor branch circuit components from overload conditions. Overload relays protect the motor branch circuit, and the motor branch circuit components from excessive heat from the overload condition. For more information on overload protection, how an overload relay works, and for an overview of the different types of overload relays, be sure to check out our next video in this series. Well, that's it for this video. We here at C3 Controls hope the information provided was helpful to you. To download the companion white paper and to find other white papers, go to c3controls.com/blog. Thank you for watching and have a great day from C3 Controls. No squirrels are harmed during the production of this video.